What's going on, guys? Welcome back to this video. Today we're going to talk about network security protocols, and this video will be part of the TryHackMe security engineer track. So let's get started. So the first thing is we're going to divide this subject based on the OZ layer or the TCP/IP layer. So basically in the OZ model we have the network layer, and we have the application layer. Also we have presentation layer. So we're going to divide these protocol into based on these layers. The first thing, as you can see here, we have in the network layer, what are the security protocols we can use to secure the communication over the network layer. So I assume, guys, you know what is the OZ model or the TCP/IP model. It's the basic of networking or connectivity. If you don't know what's the OZ model, then I recommend you guys to do some research before watching this video. So in the network layer, we have the IPsec. Also we have TLS, SSL or TLS. Actually they are different. TLS is not the same as SSL. And in the application layer we have HTTPS, we have FTPS. Additionally, for email communications we have SMTPS, POP3S, also IMAP-S. We're going to talk about the difference between POP3 and IMAP. Now in the presentation layer, so here basically goes the SSL and TLS. Okay, so in addition to these protocols on the application layer, we also have DNSSEC for DNS security. This is C here, and SSH. Okay. Before I go into further details explaining the network security protocols on the application layer and the network layer, first let's talk about SSL and TLS. So as you know, guys, SSL was created before TLS, and TLS came as a replacement for SSL, because basically now SSL is considered weak, and that's why all the protocols are switching into the replacement, which is TLS. So SSL and TLS are, as you can see, guys, used for all the network security protocols on the application layer and also on the network layer. So first, it's worth explaining how SSL or TLS works. Okay, so the first thing, the encryption used by SSL or TLS is called asymmetric encryption. Asymmetric encryption uses a pair of keys. We call them the public/private key. Okay, so what happens, say we have a sender, okay, and we have a receiver. So basically during the communication process, the sender, both the sender and receiver, they exchange their public key. Okay, so both the sender and the receiver, they know each other's public keys. Now both the sender and the receiver, they have their own private keys as well, but private keys are not exchanged, they are stored securely. So during the asymmetric encryption, what happens when the sender wants to send a packet or an email or even a single byte, what happens, the first thing, they will encrypt the message, okay, or the packet using the receiver public key. So here, let's say there is a packet. Here it will become encrypted using the receiver public key. So the receiver, I like to use arrows. The receiver public key here is used to encrypt the message, and then the message is sent to the receiver. But guess what the problem? The message now is encrypted, or the packet is encrypted. How it will be decrypted? The receiver will use their own private keys so that it becomes decrypted. That's very brief introduction about how asymmetric encryption works. The same applies here. So SSL and TLS, they use the same concept, public and private keys, to ensure that the message is encrypted and not altered. So therefore, if you are preparing for, let's say, CompTIA Security Plus, you will be asked about the confidentiality, integrity, and availability that are achieved during this process. So basically here, this process, or the asymmetric encryption, ensures that both confidentiality and integrity are maintained. How? So confidentiality, the message remains encrypted. Okay, no one can see the message. And even if an attacker was able to intercept the communication between the sender and receiver through what's called MITM attack, they will not be able to see the contents because it's encrypted, and hence they cannot modify the message. Therefore, we maintain integrity as well. So SSL and TLS again uses asymmetric encryption. Now let's demonstrate how this works in a very nice graph. Alright, so the first thing, when both the client and server want to communicate through SSL or TLS, the first thing that's going to happen, as you can see here, the client will have to send a hello message. In the hello message, we include the TLS or the version and a cipher suit that's used for the communication. And then the server, when they see the hello message, they will send, or they will respond with a hello message here, as you can see. Now in the hello message the server sends, they highlight the certificate. Okay, so all servers, like for example, as you can see, TryHackMe server, we communicate with TryHackMe server using HTTPS. Now HTTPS uses TLS. So when I communicate or send a request to TryHackMe here, TryHackMe will respond to with a certificate here. So I can take a look at the certificate. I can click on connection is secure, and here certificate is valid, and that's the certificate the server responds with when the client sends a hello. So the hello message the server responds with includes its certificate. Alright, the next step, the client now received the certificate. Now the client will authenticate. So basically the client, which is you, the browser, will make sure that the certificate is valid. How? As you can see here, if you click on connection is secure, the client, my browser, is stating that the certificate is valid. Now I can send the authentication to the server. Here, the client says to the server that the server is who they say they are. Okay, and then what happens? We create the pre-master secret. The client, which is a browser, encrypts, as you can see here, the message. In our case, if you are browsing the web, you will encrypt the contents of the web page or the packets you are sending to the web server in this step using the pre-master secret. So you create the pre-master secret by encrypting the bytes that you are sending to the server. So what you will use the server public key, as we said it earlier here in the board. We use the receiver or the recipient public key to encrypt the message. Alright, So after the pre-master secret is created, we come to the decryption of the pre-master. Now the server receives the message or the packet. Now they will be able to decrypt the contents using their private key. Okay. Now lastly, or not lastly, actually, one last step is the keys are not transmitted. We're not going to transmit the secret keys, and after the client and server both agree that the connection is secure, they will start the session. The session now is encrypted, and all the communications or all the packets exchanged are safe, and therefore we protected from the eavesdropping attacks or MITM attacks. Now back to the board. So now we have explained both how SSL and TLS work. Let's now go back to the application layer here. First, we're going to talk about HTTPS. So HTTPS is the replacement of HTTP. So as you know, guys, HTTP is the protocol used between client and server, specifically for web browsing. So it's used for web browsing. Now, when we use HTTPS, we add a secure layer to the session, as we explained here. The same process applies. Okay, so we ensure that the connection or the packets exchanged are secure, and therefore we protect it against all MITM attacks. In the case of web browsing, if an attacker is able to conduct MITM attack, they will be able to see your web activity. In addition, they will be able to see all passwords transferred. That's the problem of HTTP. All passwords and web activity is transferred in clear text between the client and the server. Therefore, when we use HTTPS, we encrypt it using asymmetric encryption, and we ensure that even if the attacker was able to perform MITM, intercepting the packets between the client and the server, they won't be able to decrypt it or view its content, meaning they won't be able to view the web activity and they won't be able to view the passwords. All right, now FTPS. So first, FTP, as you can see, it is the file transfer protocol. So again, FTP uses client server model. Okay, so what's the use of FTP? It's used for data transfer. Now, what's the addition of S? It is the word secure, and it is for, again, securing the communication between the client and the server. So in the FTP, again, the data is transferred in clear text, meaning, again, an attacker can view the packet and also can modify it. If we use FTPS, we will be able to encrypt it. Again, we have now SMTPS. Now, SMTP, POP3, and IMAP are protocols used for email communications. Now, the highlight or the difference between SMTP and both POP3 and IMAP is that SMTP is used for sending the emails. It's not responsible of receiving the emails. POP3 and IMAP are responsible for receiving the email. Receiving emails. Okay. Now, when we add S to all these protocols, we use asymmetric encryption again. Okay, to make sure that the emails exchanged are secure and encrypted. Now, one thing though is that the web server, the mail server, say you are communicating now with Gmail, and Gmail uses SMTPS for sending emails, and say it uses IMAP for receiving the emails. So when you send an email message, say you are here using your Outlook, and there's a recipient using browser. So let's say an email is sent. So here's an email, will be sent using SMTPS, and then using IMAP-S, it will be synchronized to the other end web browser using IMAP-S. So what happens here, it is encrypted here along the way, and when the browser receives it on the other end, it will be decrypted. Thing is, it is encrypted along the way, but the mail server knows the contents of the packet, meaning gmail.com can decrypt or take a look at the contents of the message. Only the service provider or the email server. But along the way here, during the communication process, the message or the email message stays encrypted, and no one from the outside, meaning an attacker using sniffing tools, will be able to view its contents. Now, to overcome this, some people don't want even the email server to take a look at the contents. That's why there is a standard called OpenPGP. It's used for encrypting, signing, and decrypting files and emails. And there is an implementation for it called the GNU-PG. The GNU-PG is an implementation of the OpenPGP standard. So basically, you can create an email message, have it encrypted, and then send it to the other end. Now, even the mail server, in this case Gmail, won't be able to view the contents because you have encrypted the message locally, and now you are sending the message in an encrypted form. For example, say you have sent hello, okay, to your friend through an email. When you use GNU-PG, the hello will be encrypted locally. Okay, so basically, when you send it through Gmail, you are not sending hello. You are not sending hello. You are sending the encrypted form. Okay, so in that case, even Gmail won't be able to view the contents. All right, now what's the difference between POP3 and IMAP? So POP3, I think we need a new page. So we're gonna have a new page. So POP3 and IMAP. So POP3 here, what happens, it will download the emails to your email client. So if you're using Outlook, the emails will be stored locally, and then the email server POP3 will delete the message. But in the case of IMAP, so here there is no synchronization between devices, meaning now, say you have opened Outlook on PC 1, okay, now you say you have opened your email on PC 2, your emails won't be synchronized between PCs. Why? Because the emails are stored locally on PC 1, so there is no chance you will be able to view them on PC 2 if you are using POP3. Now IMAP, on the other hand, it synchronizes the emails between PCs. Why? Because the emails are stored on the server, not on the client. So if you're using Outlook on PC 1, you'll be able to view the emails on the same Outlook client on PC 2. There is synchronization here because the emails are stored on the server. Okay, now to DNS security. So let's now go back to the application layer. So in DNS, as you know guys, DNS is used to resolve or to map domain names. So basically in here, domains into IPs. How? Using something called the DNS server. Now this process happens in the background. The user will not be aware of it. But when you request a domain such as example.com, what happens, your DNS server, okay, will resolve the domain name into its IP address, and therefore we'll be able to communicate with the domain name. Without this process, you're not going to be able to reach any domain name. Now, DNS security it was created to solve one critical problem, which is, let's say you are sitting in a corporate network. Okay, let's say here we have a corporate network, and here let's say we have PC A and we have PC B. Okay, and let's say here we have let's say you want to reach TryHackMe.com. Alright, let's assume now that PCB is the DNS server and PCA is the endpoint. Alright, so when you want to reach TryHackMe.com, what's going to happen? You're going to send a request to PCB because it's the DNS server. Your PC will be configured so that when it wants to communicate with any domain name, it will ask PCB. That's how you host a local DNS server. This is the case of using a local DNS server. So your corporate network here is using PCB as a DNS server. And DNS server has a list of like thousands of domain names, okay, with all their IP addresses. So when you ask PCA about TryHackMe.com, PCB will say, oh, let me search in my list and see if I have the IP address of TryHackMe. If it has the IP address, it will send you the IP address of TryHackMe and you will be able to reach TryHackMe.com. If it doesn't have, it will ask something called the root DNS servers. And these are servers around the globe that have database of million IP addresses. Alright, so let's say here, in addition to these components, we have someone, could be an internal person in the company, or it could be an attacker who have got access to the network. And let's say now we have an attacker and name him Evil. So now Evil, what he can do, or what they can do, they can say, oh, I have a DNS server. They can set up a DNS server, okay? We call it rogue DNS server. And they can intercept the packets between you and PCB. So what happens, the Evil here will state or will install their DNS server as the alternative DNS server to the original DNS server of the company. So instead of sending the request to PCB, which is a DNS server, you will send the request to the rogue DNS server. So the rogue DNS server will see that you want to access TryHackMe. So instead of sending you the correct IP address to reach TryHackMe, they will send you an IP address of their malicious site. So you have here evil.com. And evil.com is a web page that has, let's say, similar contents to TryHackMe, but it has malware. So the attacker will send you the IP address of his website. And instead of reaching TryHackMe, you will reach evil.com. And you will actually install the malware, or some JavaScripts will be executed on your end. If the browser is vulnerable, you will get compromised. So to solve this problem, they came up with DNS security. So in DNS security here, the DNS server is responsible of signing the records. They will have to sign the records, and they will have to encrypt the records using encryption. Why? Because PCA wants to make sure that they are really communicating with PCB. So how to know that? They will use PCB. They will use the PCB public key to make sure that the records are signed. When the records are signed, they validate the identity of PCB here, or the authoritative DNS server, or the original DNS server, and then they will send the packet. If they see that the records are not signed with the correct public key, they will not send the packet. That's how DNS security works. And of course, it works in the background. The user or the regular user is not aware of this process, but it's enough that they use DNS security for the communication over DNS. Okay, that's DNS security. Lastly, we have SSH. So SSH was the alternative of Telnet. So remember, in the early days of the internet, they used Telnet. Telnet works in that you connect a client here, and we have a server. So the client connects to the server to execute commands, meaning to administer the server remotely. Now, the problem is Telnet, or the packets exchanged between the client and the server, are exchanged in clear text. Again, we face the problem of MITM attacks. To solve this problem, they came up with SSH. So SSH takes the clear text and transforms the packet into an encrypted form, so that we say no to MITM. No MITM. Okay, now let's go to the network layer. So the network layer, we actually use protocols to encrypt the whole communication over TCP or UDP. So as you can see, these are the protocols on the application layer. It means if I use HTTPS, okay, I only encrypt the web activity. Okay, but let's say a scenario where you are using HTTPS for web activity, but you are using FTP for file transfer. This means that your web activity is secure, but your data transfer is not secure. Now, to solve this problem, this is not a problem actually. Let's say to expand the protection, we use the protocols on the network layer. So we have two options. We have IPsec, or we have TLS. Let's say, no, SSL is not used anymore, so we're gonna say TLS or IP security. Now, these two protocols are implemented using VPN programs, virtual private network. Now, VPN can be used on a personal level or can be used for corporates. Let's explain the difference. So let's wrap this here. All right, so in the case of personal VPN, let's give an example. My personal VPN is ExpressVPN. Now, this VPN either uses IPsec or TLS to encrypt the communication between you and any actually target or domain name or any server. Okay, so if you are using HTTP, whether FTP or even SMTP, all the communications are encrypted using this VPN. Okay, now this VPN uses either IPsec or TLS. It's one of them to encrypt all the communications. So it happens on the network layer, meaning HTTP, FTP, SMTP are all either UDP or TCP. They're actually TCP protocols, but basically the encryption happens over TCP or UDP. That's why you don't worry about other protocols such as the file transfer or the SMTP. Now, even if you use FTP during the, let's say you have turned on VPN and now you're using FTP. Now, the communication or the packets or the FTP packets, although they are exchanging clear text, but since they are wrapped in a TCP packet, they will be encrypted because the TCP packet itself is encrypted using IPsec or TLS. Now, on corporate level, they use this. Say we have an office located in site A, and we have an office, located in site B. And we have, let's say, home users, right? Now, sometimes there are resources. Let's say here we have FTP server. Here we have maybe application server. Okay, now let's say people who are on located on Office A, they want to reach the application server, but they want to do that securely. The only way to do that is to use a VPN, but they're not going to use ExpressVPN, of course not. They will be using a proprietary VPN. What does that mean? It means if Office A or Office B is using, let's say, Cisco as their firewall, Cisco comes with a proprietary VPN that you can use for to exchange packets securely between remote locations. So the firewall here has a VPN client you can install on endpoints located on Office A. The endpoints on Office A will use the VPN client of Cisco to connect to Office B, right? Same for home users. If home users want to use the application server in Office B, they need to use the VPN, okay, to connect to Office B. But what VPN? The VPN that's used by the network device hosted on Office B. In this case, it could be Cisco, could be Fortinet, it could be another solution. And that VPN either uses TLS or uses IPsec. Now, IPsec itself has two modes. It has tunnel mode, and it has the transport mode. What is the difference between tunnel mode and transport mode? In the transport mode, what happens, we encrypt the TCP/UDP header. We don't encrypt the IP header. In tunnel mode, we encrypt the TCP/UDP header. Additionally, we encrypt something called the IP header. Tunnel mode adds an extra bit of security to the exchange of the packets because it encrypts the IP header, which means your IP won't be visible. And that's the mode most personal VPNs use, because in order to hide your IP address, they need to use the tunnel mode. Okay, so that was all there is to network security protocols. Now there are some questions in the task. Okay, in this task, what is the default port for HTTPS? It is 443. In a passive FTP connection, what does the client send the first command over the command channel? Passive. So in the FTP, during the FTP exchange of packets, there are two modes, the active mode and the passive mode. So basically the passive mode is the most widely used. Here, no answers, no questions. What does PGP stand for? We mentioned this. It is pretty good privacy, and GPG is GNU Privacy Guard, which is the implementation of the OpenPGP standard. What command would you use to generate a key pair using GPG? We didn't talk about this. And consider the three following clients: rlogin, telnet, and SSH. Provide the number of the client that encrypts the traffic. It is 3. Alright, we talked about this. Now the last task is the network layer. And we can see, what does ESP stand for? It is the encapsulating security payload, which is the part in the IPsec that encrypts the packet. Which protocol does the Cisco VPN client use to establish VPN connection? We said all VPNs use either TLS or IPsec. In the case of Cisco VPN, it uses IPsec. Which protocol does the OpenVPN project use for encryption and authentication? It is the TLS. So that was it, guys, for this room.